Hi everyone, I'm Phionna,
And I'm Yujung.
and our project is investigating cyberbullying in the Twitter network. We'll first start off with introducing the problem. We want to engage in this topic because cyberbullying is a serious and prevalent issue. It impacts nearly 25% of all teens in America and has serious impacts. While there are many platforms on which cyberbullying occurs, we chose to focus on Twitter because it is a very popular social media platform among teens, and historically it has had major problems dealing with harassment. Twitter also has text and aggregate network features. Our original plan was to use Twitter API to collect timelines of tweets from randomly sampled public accounts, but we could not scrape our own data, so we settled for a 2013 dataset found on GitHub. This data was collected by polling Twitter's API for random account IDs, so each row represents a unique account, with information like handle, followers, following and statuses count, and their last tweet. Because the nature of cyberbullying is directed, we filtered for such tweets and were left with around 30,000 usable tweets. To investigate how cyberbullying correlates with network and text features, we first had to classify which tweets were instances of cyberbullying. This was a challenging problem as hand labeling was not a viable option. Taking reference from this paper, we adopted a transfer approach whereby a classifier is trained on labeled data from another platform and applied to unlabeled data of this platform. We worked with a labeled dataset of Wikipedia comments. After pre-processing the data, we obtained n-grams of the text using GenSim. This word cloud shows the top 500 n-grams of toxic comments, which we use as features for the classifier. We decided to use naive Bayes model as it is known to perform well in text classification tasks. We chose the complement NB model as it yields good overall accuracy and precision and can better handle imbalanced dataset. We then applied the classifier to the tweets and found that around 10% of our dataset was labeled true. To evaluate this approach, we computed the cosine similarity of the top 800 n-grams from each dataset. We found a 69% similarity when using weighted average. This low similarity can be attributed to the fact that these two platforms have different social contexts. However, we did find a higher similarity for bullying comments, which helps to validate our approach. After we identified the cyberbullying comments, it is now time to analyze the features of these comments and their authors to see if anything interesting emerges.
We analyzed the textual features and network features. In the network features, we randomly sampled 200 out of 2,900 comments to observe the graph structure. It turns out that the network is very peripheral, and few nodes have many edges within the network, which means that among people who post bullying content, only few of them target multiple subjects. Next, we look at the network of victims. The node that has the highest in-degree centrality represents the most bullied person. The result shows that Justin Bieber is the most bullied account in our Twitter dataset. We also ran the t-test to identify the statistical difference between bulliers and non-bulliers. It shows that only the statuses count, which is the number of tweets, is significantly different between the two groups. But we can see the bullying group is more active on the platform, since they have on average more followings and followers. For textual features, we apply Look to compare textual features between Wikipedia comments and Twitter. For both platforms, the bullying comments are much more negative, but for the Wikipedia comments, the scores are much higher, probably because on average each comment is longer than each tweet. We also explored the network of words in the bullying tweets. We created an edge for every pair of words that occur in the same post. The highest degree centrality node in the sample network is do not. We can use the relationship between these tweets to further increase precision of classification. To conclude, we identify some limitations and future improvements. First, there was a lot of false positives. On the left are actual toxic comments, but on the right are wrongly identified comments. Second, the similarity score between two datasets is only 68%. We need to get data from other social platforms to increase performance of our classifier. Besides, because we only have one tweet from every account, we do not have enough historical data to identify that person as a cyberbully. Last, we found the network of bullying is very dispersed, so we cannot apply robust network analytics tools. We hope to obtain a larger, well-structured data on social media for future improvements, to explore more features and more relationships of cyberbullying. We also listed some questions that future research could try to answer. Thank you for listening.